Okay, class. So today I will be reading a small excerpt of an article on law of conservation of matter. Be sure to pay close attention, especially to any words that may or may not sound familiar to you, so that if there's something that you'd like to review after we're done reading, we can discuss it further. So I'm going to read this passage and you will listen and follow along with me as I do that. So, matter is anything that has mass and takes up space. It includes molecules, atoms, fundamental particles, and any substance that these particles make up. Matter can change form through physical and chemical changes, but through any of these changes, matter is conserved. The same amount of matter exists before and after the change. None is created or destroyed. This concept is called the law of conservation of mass. Consider the plants and algae living in and along the stream. In a process called photosynthesis, these organisms convert light energy from the sun into chemical energy, which is stored in sugars. However, the light energy doesn't produce the atoms that make up those sugars. That would break the law of conservation of mass. It simply provides energy for a chemical change to occur. The atoms come from carbon dioxide in the air and water in the soil. Chemical energy allows these bonds to break and reform to produce sugar and oxygen, as shown in the chemical equation for photosynthesis, which reads 6CO2 plus 6H2O plus light. So these reactants become the products C6H12O6, or sugar, plus 6O2. This equation says that six carbon dioxide molecules combine with six water molecules to form one sugar molecule and six molecules of oxygen. If you added up all the carbon, hydrogen, and oxygen atoms on either side of the equation, the sums would be equal. Matter is conserved in this chemical change. Matter is also conserved during physical and chemical changes in the rock cycle. As a stream carves deeper into a canyon, the rocks of the canyon floor don't disappear. They're eroded by the stream and carried off in small bits called sediments. These sediments may settle at the bottom of a lake or pond at the end of the stream, building up in layers over time. The weight of each additional layer compacts the layers beneath it, eventually adding so much pressure that new sedimentary rock forms. This is a physical change for the rock, but with the right conditions, the rock may chemically change too. In either case, the matter in the rock is conserved. So think about that for a second. Matter in the rock is conserved. Since we are attempting to develop and use a model to describe how the total number of atoms does not change in a chemical reaction, and thus mass is conserved, I want you to think about how is this reading relevant to what we are learning about today. So, how does the reading that I just did on matter, how does it relate to number of atoms not changing in a chemical reaction? How is mass conserved even though a chemical reaction is taking place? Why don't those atoms disappear? Or what happens to them? Why do they move? Um, how is that energy conserved? And can you provide your own example of the law of conservation of matter? What is the law of conservation of matter, and how can you apply that to show that matter can't be created or destroyed? And lastly, why do you believe that the author decided to include multiple examples of matter being conserved?